Welcome to free lecture series in Tamil for all electrical competitive exams. For more free lectures, kindly subscribe and share our channel with your friends. Keep supporting.
Good morning all. Am I audible? Please let me know in the comment section. Okay, I hope I am audible. So let us start this session. So we are discussing about transmission and distribution. So already we have seen many formulas, many methods and how to crack the questions. Almost 50% of that chapter is completed. Let us see the remaining portion and let us see few more questions, how to tackle the questions that was already asked in your previous year exams and some new questions also. Let us see all of them one by one. First question is, to equalize the sending end and receiving end voltages, impedance is connected. The impedance is connected at the receiving end of the transmission line having the following ABCD parameter. So they said A and B equal to 0.9 and B equal to 200 at an angle of 90 degree. The impedance so connected would be dash. That is the given question. It's really quite interesting. Let us see how to tackle this question. So anyway, all the parameters were clearly given to us. With the help of the given parameters, let us try to catch the answer. First, understand the question carefully. Question la enna sollirukanga, if you observe the question carefully, they told there is a transmission line. Okay, usually we are modeling the transmission line with the help of ABCD parameter. So let us take the transmission line. Let me design. Let us assume we all know we are designing the transmission line with the help of ABCD parameter. Already this transmission line is implemented and it is designed. Now what they are doing is, if you observe the question carefully, the impedance is connected at the receiving end of the transmission line. So this is the receiving end. Here we are going to connect one impedance. Let us take the impedance value is Z. And at the receiving end, the voltage that we are having is called VR and the current that we are receiving is called IR. So receiving end will going to receive a current is called simply IR. Okay sir, we are simply calling it as IR. Next, from the sending end we are going to pass some voltage, we are calling it as VS, and its corresponding current, let me call it as IS. Anyway, already what we know, transmission line has certain ABCD values that is already here. Next, அவங்க என்ன வேல்யூ கொடுத்திருக்காங்க அப்படின்னா combined data. If you observe the question carefully, to equalize the sending end voltage and the receiving end voltage, in order to bring the value of VR as equal to VS, in order to bring this condition, they are connecting a certain amount of impedance at the receiving end. After that, what will happen? Because of the connection of this impedance into the existing transmission line, you will get a new set of ABCD parameter. Let me call it as A dash, B dash, C dash, D dash. That is very beautiful question. A dash, B dash, C dash, D dash. So here the conclusion is what we need to find. We have to find out the new ABCD parameter. Already this is the given ABCD parameter and this new ABCD parameter only given in your question. That is A equal to D equal to 0.9 and B equal to 200 at an angle of 90 degree. Like that they have given the parameters of the new network. After completing, after reducing this whole network into a single equivalent network, we can compare our resultant value with the given values, such that we will get the solution for the impedance. Question enna ketirukanga, we have to identify the value of this Z with the help of this given data. That's all. I hope you all have understand the question. Let us try to reduce. Okay. First of all, ABCD parameters are cascaded. Cascaded means we will connect them in series. So let me break this network into two off. The first network is having a certain ABCD parameter. I am just calling it as A, B, C. That is existing line. Next we are connecting one more impedance at the receiving end. Let me call it as Z, that is impedance at the receiving end. Now this current that is receiving here, it is called receiving end current, and here we are going to consider receiving end voltage. From the sending end we are going to pass a voltage is called Vs and current is called Is. Sir, I am just breaking the network into two of ABCD parameter already existing. இது தனியா பிரிச்சிருங்க. இப்போ கொடுத்திருக்க நியூ நெட்வொர்க் இம்பிடன்ஸ் கனெக்ட் பண்றாங்களே அதை மட்டும் தனியா எடுத்துக்கிட்டு அதோட ABCD parameter கால்குலேட் பண்ணுங்க. And then we can cascade. ABCD parameters will be cascaded each other. இதோட ABCD parameter நீங்க இப்ப find பண்ணணும். First write down the equation. Sending end voltage equal to A times of receiving end voltage plus B times of receiving end current. Similarly, sending end current equal to C times of receiving end voltage plus D times of receiving end current. Now we know all the parameters, ABCD parameters. Exactly, we know all ABCD parameters. Sorry, we know all expression, and we know how to identify the ABCD parameter. Step number 1, make the receiving end current equal to 0 ampere. According to two-port network, we know how to calculate the ABCD parameter. When we are trying to find out the value of A and C, we should make the value of IR, receiving end current, as 0. Current 0 means receiving end will be open circuited. I'm just making the value of receiving end current as 0. For receiving end current on the 0 அப்படினா what will happen? இப்போ equation அப்ப என்ன வரும்? Sending end voltage Vs equal to A times of receiving end voltage. Similarly, sending end current Is equal to C times of Vr. Very simple. Now if you observe the circuit carefully, when the receiving end current will become 0. இப்போ receiving end current வந்து 0 ஆயிடுச்சு அப்படினா transmission lineல எந்த டிராப்பும் இருக்காது, எதுவுமே இருக்காது. See, here we are having sending end voltage, here we have the impedance just and here we have the receiving end voltage. Now please tell me, what is the difference between sending end voltage and receiving end voltage? Is there any impedance drop in between this? No. Whatever the voltage that will appear here, same voltage will appear here also. So it clearly denotes that the value of Vs and Vr are going to be equal. When Vs and Vr will become equal, and just from this what we can say, Vs Vr equal abdina, it could be possible only when the value of A will become equal to 1. So from the network we found the value of A equal to 1 for the new network. Similarly, what will be the value of C? See, this is the impedance, right? We are making the receiving end current only as 0, not sending end current. Actually here I think I placed it at the wrong place. Don't confuse, this is receiving end current, right? So we are attaching the impedance like this. So when receiving end current will become 0, but sending end current still it is present, right? The sending end current will go. After that what will happen? Here it cannot go because we are already open circuiting this terminal. So it will be 0 ampere. So this sending end current will be diverted through the impedance Z and then it is coming back. So now what I can write is, from this receiving end voltage Vr equal to the voltage drop across the impedance. Correct? Alternative way, it can also be written as Is into Z. From this what I can say, the value of Is equal to Vr divided by Z. See, finally what we got, Is equal to 1 by Z into Vr. See there, Is equal to C into Vr, here Is equal to 1 by Z into Vr. So from this what we found, the value of C equal to 1 by Z. Next parameter we found now. So we found two parameters now. Value of A we found equal to 1 and the value of C also we found, that is 1 by 2. Since we are designing actually ABCD parameter, by default I told you, while calculating the problems based on ABCD parameter, you can assume that the line is short transmission line. Your line, okay, though you don't know the value of ABCD values at all, எதுமே உங்களுக்கு தெரியாது அப்படி நீங்க வச்சிட்டாலும், just for the purpose of analyzing you can just assume network is symmetrical. When the network will become symmetrical, then the value of A and B will become what? It will be equal. So I can say A and D equal to 1 and C equal to 1 by Z. Now we have to identify the value of B, next target. Anyway, D oda value namakku theriyum. Anyway, you can try, sir. One more thing. இது வந்து you no need to assume that short transmission line assume பண்ணி தான் போடணுமா அப்படின்றதெல்லாம் கிடையாது. You can just follow the standard procedure. ABCD parameter கொடுத்திருக்காங்களா, ஓகே, ஜஸ்ட் ABCD parameter and then receiving endல வந்து impedance கனெக்ட் பண்றோம், அதுக்கு தனியா அதோட ABCD parameter ஃபைண்ட் பண்றீங்க and then ரெண்டு நெட்வொர்க்கையும் காஸ்கேட் பண்ண போறோம், அவ்வளவுதான். That's all. You no need to remember anything, right? Don't get confusion. Okay sir, now we found the value of A, we found the value of C, right? If you want to calculate the value of D separately, you can calculate. There is nothing because we don't know at sometimes how we know whether it is symmetric or reciprocal while directly facing the network. That confusion may arises. So you can, in that cases, you can separately calculate. How will you calculate it separately? Let me teach you. In that case, so we found the value of A and C, that is 1 by 2, right? So let me remove all these things. A and C will become 1 by 2. 1 minute. Okay. So we found the value of A 1, C 1 by Z. Let us take the same network again, and here we are attaching the impedance parameter, right, at the receiving end port. So here we are passing the sending end current, and here we are going to receiving the receiving end, and here the value of the voltage is going to be receiving end voltage, and here it is going to be sending end. Okay, sir, everything is fine now. Let us proceed further. So from this, so this is impedance Z. While calculating, let me write the expression once again. Sending end voltage can be written as A times of receiving end voltage plus B times of receiving end current. Many of you may have one more doubt here. Sir, ABCD parameter write பண்ணும்போது நம்ம இங்க என்ன பண்ணிருப்போம் அப்படின்னா மைனஸ் போட்டிருப்போம். ரிசீவிங் எண்ட் கரண்ட்டுக்கு வந்து -IR னு போட்டிருப்போம். ஆக்சுவலா இங்க மைனஸ் தான் வரும். But if you observe the direction of the current in two-port network, I kept minus. Why? Because in two-port network, receiving end current will enter into the network. Here I have reversed the direction of current. When the direction of the current is reversed, then polarity will change, then it will become positive. That's why I kept plus here. I hope many of you noticed. Let us see the next parameters. Let us make the value of VR equal to 0. Receiving end voltage will become 0. In the sense what? It will be short circuited like this. So now we kept the impedance since here. When receiving end is short circuited, its parallel impedance will become what? Useless. Why? This is Z. Impedance offered by the short circuit line is 0. If you find out the overall impedance, it will be 0 into Z divided by 0 plus Z. So it will be 0. Net value will be 0. So simply your network will become short circuited line like this. Now, if you observe, here we are having our sending end voltage. Tell me, what is the value of sending end voltage now? Sending end voltage will become 0. Why, sir? So, since it is short circuited, if your entire line will be short circuited, then what will be the net voltage? It will be 0. So, sending end voltage will become 0. But in short circuit line, sending end current will not be 0. Okay, let us proceed further. When we are making the receiving end voltage as 0, then the parameters will become sending end voltage Vs will become equal to B times of IR. Since the value of Vs will become 0, so I can say the value of B will be 0. First conclusion. Next, for the second parameter D, if I write the expression for D, Is equal to D times of IR. But if you observe the circuit carefully, see that this is sending end current, it is going. Here at the receiving end, we are passing a current is called receiving end current. Sending end current and receiving end current both are same or not in this case? Yes, it will be same. It means the value of D will become 1. So finally we found the value of ABCD of the given new network. Now let us go through. Guys, you may think that this question is very big, but don't think like that, because this question is not big question. At very first time I am teaching this to you. Because of that I am taking a lot of time. Don't think that question is big one. And this model is very familiar model. Once you understand the one question, you can crack many questions. Let me substitute the new ABCD parameters. 1, 0, 1 upon Z, 1. That is the new. Now what is the total network parameter? Already existing network is having ABCD. New network parameter will become 1, 0, 1 by Z, 1. Both are cascaded. ABCD parameter means always cascaded. Now let us reduce the network. Multiple பண்ணுங்க. A into 1 will become A plus B into 1 by Z will become B upon Z. Similarly, A into 0 will become 0 plus B into 1 will become B. Next, C into 1 will become C plus D upon Z. Next, C into 0 will become 0. It will be D. So this is the complete ABCD parameter. This value only given in your examination. Sorry, in your question. இப்போ நான் அதை கம்ப்ளீட்டா என்ன சொல்றேன் அப்படின்னா A dash, B dash, C dash, D dash. I am just calling like this. இந்த parameter தான் already networkல கொடுத்திருக்காங்க. The value of A is 0.9 and the value of B is 200 at an angle of 90 degree. Since A and D, right? So okay, let me keep D also same na, 0.9 at an angle of 0 degree. Value of C is not given. Okay, that may not be required. Let us see. If we compare பண்ணீங்கன்னா, see here what we obtain A plus B upon Z equal to what we got? We got 0.9. Am I right, sir? The total value equal to 0.9. From this, what I can say is B upon Z equal to 0.9 minus A. Next step from this, Z equal to B upon 0.9 minus A. Finally, let us substitute all the values. B is already given. What is the value of B? B is given as 200 at an angle of 90 degree divided by 0.9 minus, we have to substitute the value of 1 second. Okay, 1 minute guys. Here there is some mismatching, right? See what they have given. They given it as the total network value, right? So to equalize the sending and receiving voltage, the impedance is connected at the receiving end of the transmission line having following ABCD parameter. Okay, chalo, I misunderstood. 1 minute, guys. Everything is fine. There is a small misunderstanding. Let us see. See, the data is given as, see there, that is given as ABCD, not equivalent value, right? I misunderstood the question. Forgive me. What it was given, the impedance is the question. Now see there, the transmission line is having the ABCD, following ABCD parameter. It means it is not equivalent parameter, na? It is already existing parameter. This values, this ABCD value only given, not the resultant value. That means they are treating it as short transmission line by default, right? So yes, our assumption is correct. Let me go through. Listen guys, given it is, I already told you now, when there will be no network is given, in this case ABCD parameter மட்டும் கொடுத்துட்டு எந்த transmission line அப்படின்னு clear பேசுற அப்படின்னா by default you can take that is a short transmission line. I thought that they didn't went with this assumption, but they went with this assumption only. Then only you can crack this question. Short transmission line oda net ABCD parameter oda value enna? Value of A equal to 1. Value of D also equal to 1. Am I right, sir? We all know these parameters. And yes, so this is enough, right? So now we know the value of parameter A, and we also know the value of parameter D, and we can substitute the value of parameter C will become, that is B will become Z, and C will become 0. These are all the ABCD parameter of the short transmission line. Short transmission line means like this, equivalent circuit of the short transmission line. We can write sending end voltage equal to Z times of sending end current or receiving end current, right? So plus receiving end voltage, it means the value of A equal to, 1 minute, I am comparing it to receiving end voltage, right? So value of A equal to 1, value of B equal to Z. Similarly, if you write second expression, sending end current equal to, from here I can say sending end current equal to receiving end current. Directly I can say, it means what? Value of D will become 1 and the value of C will become 0. இதெல்லாம் நம்ம ஏற்கனவே short transmission line க்கு டிசைன் பண்ணிருப்போம். That is the equivalent parameter. What you need to do is, நீங்க டோட்டலா கால்குலேட் பண்ண இம்பிடன்ஸ் ஷார்ட் டிரான்ஸ்மிஷன் லைனோட நெட் இம்பிடன்ஸ் கூட கம்பேர் பண்ணி பார்க்கணும். So what the small confusion I made is, அவங்க கொடுத்திருக்கிறது already exist ஆயிருக்க ABCD parameter, right? And I misunderstood the question. நான் total value கொடுத்திருக்காங்கன்னு நினைச்சிட்டேன். That is the only correction. And let me repeat again, when there will be no data about the type of the transmission line, what you need to do, you have to, by default you have to assume that the given transmission line is short transmission line. Okay, let us proceed now. Now you will get the answer. So what we know now is the value of A plus B by Z, that is the total impedance, that will be equal to 1. So that is the total A. This total value will be considered as total A of the short transmission line, that will be equal to 1. From this, what we can suggest is, if you calculate the value of impedance Z, it will be 1 minus A. From this, Z equal to B upon 1 minus A. Now what is the value of B here? Now it is already given in the question, 200 at an angle of 90 degree divided by 1 minus, what is the value of A? 0.9. If you reduce this, it will become what? 200 divided by 0.9. 1 minus 0.9 will become 0.1 at an angle of 90 degree. So 200 by 0.9 will become 2000. So 2000 at an angle of 90 degree. Finally, we got the answer now. Yes, sir, we got the answer. So the correct answer is option C. We got the answer, right? Yes, sir. I hope you all have understood. Sorry for the misunderstanding of the question, right? Let us go through the next one. Next என்ன கொடுத்திருக்காங்க, the ABCD parameter of the three-phase overhead transmission line are given as A, B, C, everything is given. At a no load condition, the shunt inductive reactor is connected at the receiving end line to limit the receiving end voltage to become equal to sending end voltage. Then the ohmic value of the reactor, same model as the previous one. Nothing, there is nothing changes. Same question now. Just you have to solve in the same way that we have solved the previous question. என்ன பண்ணுவீங்க, see, அவங்க என்ன பண்றாங்க, receiving endல reactor connect பண்றாங்க. This is asked in gate. This is asked in IES. See how the models are getting repeated. Anyway, nothing is there. நம்ம என்ன பண்ணுவோம், now we know the total impedance. நமக்கு என்ன தெரியும், receiving endல நம்ம ஒரு impedance வந்து impedanceக்கு பதிலா இங்க reactor connect பண்ணிருக்காங்க. whatever it is, ஒரு reactor connect பண்ணாலே total parameter வந்து என்ன வரும் அப்படிங்கறது நம்ம இப்பதான் பார்த்தோம். net parameter என்ன வரும், A plus B by Z. Here it is B and here it will become, so actually I have not calculated this value. I hope I have done. C plus D by Z only, correct? Yes, I have done. And this value is D. We know the value of ABCD here. Total value we know. So நம்ம என்ன பண்ணிக்கலாம், this is the total impedance. This will be equal to short transmission line oda net impedance. What? 1 Z 0 1. Right, sir. அப்ப இது ரெண்டுத்தையும் கம்பேர் பண்ணி நீங்க என்ன பண்ணிக்கலாம், once again you can calculate the value of reactance directly. A plus B by Z equal to 1. From this, the value of Z equal to 1 minus, sorry, first pass this A to the left hand side, so it will become B divided by 1 minus A, right? Z equal to B upon 1 minus A. Substitute all the values. Value of B is given as 200 at an angle of 90 degree upon 1 minus value of A is, I think, same question, huh? Yes, same question, I hope. It will be 0.9. See, I have not noticed this. So it will be again same 2000 at an angle of 90 degrees. So the correct answer is what? Option B. Without changing the data, I think it was getting repeated. Okay, let us go through the next one. Next question. The generalized circuit constants of a three-phase 220 kilo voltage rated medium length transmission line is having ABCD parameters. If the load at the receiving end is 50 megawatt at 220 kilovolt with the power factor of 0.9 lagging, the magnitude of the line to line sending end voltage will be dash. So the question is, we have to find out the line to line sending end voltage. Okay. Before calculating all this parameter, I would like to ask you a small question. We are calculating ABCD parameter, right? Yes, sir. While calculating ABCD parameter, whether we are using per phase voltage, per phase current, or three phase voltage, three phase current, whether we are using phase voltages or line voltages, that is what my question. So the conclusion is, when we are calculating ABCD parameter, the mandatory thing is you must kept all the voltages. You have to consider all the parameters per phase. Okay, don't forget. So if the line voltage will be given in the question, you will have to convert it into phase voltage. But you don't need to bother about the current. Why, sir? Since our transmission line is implemented with the help of star connection. In case of star connected network, line current and phase current are always equal. So there is no point of worrying about the current. Either you are traveling along with the phase current or line current, both are equal. But while traveling along with the voltage in our transmission line, make sure whether you are traveling along with the phase voltages or not while traveling with the ABCD parameter. That is very important. Let us take the question. Okay, sir. Now the question is, the given question is, they are considering this transmission line. In the transmission line, it was clearly given as what they have given. The receiving end power is clearly given. How much it is? 50 megawatt. First step, collect the data. And then receiving end voltage also given. How much it is? 220 kilovolt. Okay, sir. But that is line to line voltage. Next, power factor also given. How much it is? 0.9. Okay, sir. Everything is fine. Given it is ABCD parameter. In terms of ABCD parameter, how will you calculate the sending end voltage? Sending end voltage equal to A times of receiving end voltage plus B times of receiving end current. But all the parameters you must consider per phase. Okay, sir. At last, you can calculate the line voltage. What you need to do is first convert all things into per phase. At the end, again, sending end voltage நீங்க திரும்ப என்ன பண்ணிக்கலாம் லைனுக்கு மாத்திக்கலாம் பிகாஸ் அவங்க கண்டிப்பா என்ன கேட்டிருப்பாங்கன்னா ரிசீவிங் end voltage லைன் டு லைன்ல இருக்கு இல்லையா சென்டிங் end voltage லைன் டு லைன்ல தான் கேட்டிருப்பாங்க கண்டிப்பா பை டிஃபால்ட் அது per phase இருந்தா அவங்களே क्वेश्चनல மென்ஷன் பண்ணிருப்பாங்க always in three phase system they will travel along with the line to line RMS voltage only. இதை தவிர வேற ஏதாச்சும் வோல்டேஜ் அவங்களுக்கு தேவைன்னா அவங்களே கேட்பாங்க கால்குலேட் தி பர் ஃபேஸ் வோல்டேஜ் அந்த மாதிரி அவங்களே மென்ஷன் பண்ணுவாங்க இப்போ கால்குலேட் தி பீக் வோல்டேஜ் அந்த மாதிரி மென்ஷன் பண்ணுவாங்க until otherwise until நீங்க என்ன பண்ணிக்கலாம் given it is RMS line voltage எடுத்துக்கலாம் by default. Let us proceed. Now value of A is already given in the question. Value of A is given as 0.936 at an angle of 0.98 degree. And the value of B is given as 142 at an angle of 76.4 degree. So the value of A is known, value of B is known. What about the receiving end voltage? Receiving end voltage VR is given as 220 kilovoltage. But just now I told you we cannot consider the line voltage. So divided by √3 in order to obtain the per phase voltage. Now what is the unknown parameter? Sir, I know A now, VR know, B known, but IR is not known. In order to calculate the value of IR only, receiving end current only, they have given these many data. Let us calculate. We all know real power receiving end 3 phase can be written as √3 times of receiving end voltage into receiving end current. From this I can say the value of receiving end current will become receiving end power PR divided by √3, sorry I left cos pi, √3 times of VR into cos pi. Now substitute all the values. Given it is 50 megawatt, 50 into 10 power 6 upon √3 times of receiving end voltage is 220 kilovoltage. See, this is the expression for line parameters. Okay, I am not using per phase parameters. So into cos pi, power factor is 0.9. If you reduce this expression, you will get the value for IR. Once you get the value for IR, very simple, just to go back to the question, substitute all the parameter, get the expression for VS. But don't forget that you are calculating per phase voltage. From that you can calculate line voltage equal to √3 times of per phase voltage. I hope I had given all the idea. Now you can simply solve the question and you will obtain the answer. Okay. So in ABCD parameter today we saw some very beautiful model. I hope you all have understand. If you don't understand, just rewatch the lecture one more time. Nothing is there, but you have to understand how to solve the questions. Okay. Go with your own methods. That is very important. Okay, sir. Now, the next question is the maximum efficiency in the transmission line. That is transmission of bulk AC power will be achieved when the power factor of the load. Load or the power factor we can achieve the maximum efficiency. That is the question. So that is very simple. Kindly go through the notes. I am giving a small hint for this because I cannot solve this. All those things I cannot prove it here. So what my suggestion is, you please go through the notes once. Actually, என்ன ஆகும் அப்படின்னா AC transmission lineல maximum power வந்து நமக்கு transmit ஆகணும் அப்படின்னா, right? While transmitting, that is maximum efficiency. Maximum efficiency வந்து நீங்க achieve பண்ணணும் அப்படின்னா, condition for maximum efficiency, not for maximum power transfer, right? Please go through the question carefully. So maximum efficiency வந்து நம்ம achieve பண்ணும்போது என்ன ஆகும் அப்படின்னா bulk power, right? So the maximum efficiency in the transmission line of bulk AC power will be achieved when the power factor of the load, actually அது என்ன வரணும் அப்படின்னா leadingல தான் இருக்கும், but it is getting close to unity power factor. That is the point where we are achieving the maximum efficiency. So what is the answer for this question? The answer for this question is option B. Kindly go through the notes. We have been proved for these things. Okay, let us take the next one. Next beautiful question is the characteristic impedance of the transmission line with the series impedance Z is given per unit length and shunt admittance Y also given per unit length. Now how will you write the characteristic expression? This is also theory question. We know the answer for this. Let me write the answer directly. The characteristic impedance of the transmission line can be simply written as square root of Z upon Y. First conclusion. Yes, sir. Actually, it can also be written as Zc equal to Z upon gamma. Whereas gamma is what? We found there are three types of constants, right? I hope you all have remember. But gamma can be written as, that is propagation constant, right? So gamma can be written as square root of y into z. If I substitute, it will become z upon square root of z into y. It can be further written as square root of z by y. Z by y. That is what we were written here. Whereas the value of z can be written as r plus j omega l divided by conductance g plus j omega c. That is the value of admittance. This is the value of impedance in the denominator and numerator. When your transmission line will become lossless, suppose if the line is lossless, then what will happen? Lossless line means resistance and conductance value will become 0. Then the network can be simply written as j omega L by j omega C. J omega getting cancelled, so it can be finally written as L by C. So this is one more impedance, one more way of writing this expression. Another way is, this characteristic impedance can also be written in terms of ABCD parameter, A into B upon C into D. It can also be written, right? So here I am writing the characteristic impedance in terms of ABCD parameter. So here what we have understood, we can also write it in terms of L by C. You can also write, actually that is ABCD parameter means we are calculating open circuit and short circuit parameters. So you can also calculate the characteristic impedance in terms of open circuit impedance and short circuit impedance. Actually, that is ABCD parameter only. This is, if you go along with the A by C, this is open circuit impedance. B by D will become short circuit impedance. So if I replace it by open circuit and short circuit, these all are derivations, theory. It is in your notes. Kindly go through it. So we can also write the characteristic impedance in terms of the open circuit impedance and the short circuit impedance. So these are all the many way of writing the characteristic impedance. Now coming back to the questions, let us solve all the questions at a single time, because we have gone through all the basics now. Now the first question is characteristic impedance. Now we know the answer, that will be Z by Y. Yes, option C is the correct answer. Next, the open circuit short circuit impedance of the lossless line are respectively Z1 and Z2. Then the characteristic impedance will become what? Square root of Z1 and Z2. I just now I told you that is the product of open circuit and short circuit. So that is correct. Last question. The transmission line is having this section of input impedance is 36 and 64 ohm respectively when short circuit and open circuited. So this is a short circuit impedance. This is short circuit. First one is short circuit, second one is open circuit. Then what is the answer? Answer will be square root of product of short circuit impedance into open circuit impedance. அப்ப ரூட்டுக்குள்ள என்ன சப்ஸ்டிட் பண்ணோம்? 36 into 64. என்ன ஒரு ரூட்டுக்கு வெளியில 36 வெளியில எடுத்தீங்கன்னா 6, 64 வெளியில எடுத்தீங்கன்னா 8. It will be 48. So what is the correct answer? 48 ohm is the correct answer. Option D. It's very clear now? Yes. Let us go to the next board. Okay, sir. The question is, a fixed value of the complex power flow in a transmission line having the sending end voltage V, the real power losses will be proportional to dash. So now you must think. ஆப்ஷன்ல என்ன கொடுத்திருக்காங்க அப்படின்னா, ஆக்சுவலி டிரான்ஸ்மிஷன் லைன்ல வந்து இப்ப நீங்க கொஸ்டின் வந்து ரீட் பண்ண உடனே அவங்க என்ன கேட்டிருக்காங்க, ரியல் பவர் லாஸ் அப்படின்னாலே நம்ம மைண்ட்ல வந்து என்ன ஓடும் அப்படின்னா I2R தான் வரும். பை டிஃபால்ட் லாசஸ் ஆஃப் தி டிரான்ஸ்மிஷன் லைன் கேன் பி ரிட்டன் as I2 into R. ஓகே சார். நான் இப்போ உங்ககிட்ட என்ன கேட்க போறேன் அப்படின்னா, கொஸ்டின்ல வந்து நீங்க கேர்ஃபுல்லா அப்சர்வ் பண்ணி பாத்தீங்கன்னா ஆப்ஷன்ஸ் வந்து இன் டர்ம்ஸ் ஆஃப் ஐல கிடையாது, வில இருக்கு. அடுத்தது வந்து இப்ப என்ன அப்படின்னா, டிரான்ஸ்மிஷன் லைன்ல என்ன டேட்டா கொடுத்திருக்காங்க? Observe the question carefully. The given data for a fixed value of the complex power flow, they are talking about complex power. First of all, that is apparent power. Complex power flow in a transmission line having the sending end voltage V. அப்ப அவங்க டேட்டா வந்து என்னென்ன கொடுத்திருக்காங்க அப்படின்னா, they have given only two datas. One is complex power, another one is voltage. இவங்க ரெண்டு பேரை வச்சு நம்ம என்ன பண்ணோம் அப்படின்னா லாஸ்க்கான பாராமீட்டர் கொண்டு வரணும். I hope you are getting me. So let us see. First of all, complex க்கும் voltage க்கு நம்ம expression எப்படி எழுதுவோம்? Complex power can be written as it is the product of voltage I into current I conjugate. That is the general expression. If you consider only magnitude, then it will become S equal to V into I. First conclusion. Exactly, sir. From this, what I can suggest is The value of the current I can be written as complex power S divided by V. I hope I am correct. Yes sir, exactly correct. அப்ப நம்ம என்ன பண்ணிக்கலாம், losses வந்து நம்ம calculate பண்ணோம் sir, but நம்ம கிட்ட கொடுத்திருக்க parameters வந்து only what, காம்ப்ளெக்ஸ் பவர் பத்தி பேசியிருக்காங்க, வோல்டேஜ் பத்தி பேசியிருக்காங்க. From this I have to derive the expression for complex losses. That is the beauty of the question. And you know one more thing, they are called base quantities. நம்ம என்டையர் பவர் சிஸ்டம்ல இந்த ரெண்டு குவாண்டிட்டி தான் வந்து எப்பயுமே நோன் குவாண்டிட்டிஸா இருக்கும். அதனாலதான் கொஸ்டின் இப்பவுமே அதை வச்சுதான் கேட்டிருக்காங்க, ரைட்? லெட் அஸ் see how to derive. இப்போ நம்ம என்ன பண்ணலாம், கரண்ட் வந்து in terms of complex power and voltageல எழுதலாம். எப்படி எழுதுறது? I can be written as S divided by V whole square into R. Any mistakes sir in my calculation? No, there is no mistakes in our calculation. We have done everything as per the given representation. Okay sir, so from this how can you write this expression? If I replace current I by S by V, I will substitute பண்ணீங்கன்னா you will get what, S square divided by V square. Is there any doubt so far? No sir, there is no point of having doubt sir. Next நீங்க என்ன பண்ணணும், now you can find the relation between losses and voltage. Easily you can identify the losses and voltage. Can anyone please identify and tell me the answer? Now what will be the answer now? Answer for this question is what? It will be inversely proportional to V square. Yes, I am correct because we got the relation now. So losses equal to, or we can say sir, it can be written as S square into R upon V square sir. In terms of, anyway, transmission line losses are definitely mandatorily the value of R is required. You cannot negotiate the value of R. So I will just keep R itself. So from this what I understood, according to the given data, losses is inversely proportional to 1 upon V power 2. That is directly proportional to 1 upon V power 2. So the correct answer is going to be option C. Very simple question, but little thinking is required. Oh, question, I hope data are visible. Let us go through. This is a very important and a very good question. I think asked in gate only, na? Yes. So let us read this question. Consider the model shown in the figure of the transmission line with the series capacitor is connected at the midpoint. Enga connect pannirukanga? Here. Okay sir, it is connected at the midpoint. The maximum voltage on the line is at the location. The maximum voltage on the line is at the location. அப்ப கொஸ்டின்ல என்ன கேட்டிருக்காங்கன்னா, this is the given network. Simple KVL. ஸோ இப்போ நெட்வொர்க்ல வந்து நம்ம அப்ளை என்ன கேட்டிருக்காங்கன்னா, இந்த நெட்வொர்க்ல வந்து நீங்க இந்த பாயிண்ட்ல ஸ்டார்ட் பண்ணி இந்த பாயிண்ட்ல முடிகிற வரைக்கும் டிஃப்ரெண்ட் பாயிண்ட்ல வந்து வோல்டேஜ் வந்து எஸ்டிமேட் பண்ண சொல்லியிருக்காங்க. அப்சர்வ் தி ஆப்ஷன் P1, P2, P3, P4 எங்க இருக்கு? திஸ் இஸ் P1 ஸ்டார்டிங் பாயிண்ட், திஸ் இஸ் P2, திஸ் இஸ் P3. they left the dot here, add it. this is P4. இப்போ இந்த 4 பாயிண்ட்ல எந்த இடத்துல வந்து உங்களுக்கு வோல்டேஜ் வந்து மேக்ஸிமமா கிடைக்கும் அப்படிங்கறதான் क्वेश्चन. ப்ரொசீட் பண்ணலாமா? தட் இஸ் வெரி நார்மல் क्वेश्चन. let us see one thing I would like to tell you. பவர் சிஸ்டம் பொறுத்த வரைக்கும் நீங்க சர்க்யூட் தியரில ஸ்ட்ராங்கா இருந்தீங்கன்னா எல்லாத்தையுமே சால்வ் பண்ணிடலாம். we may think that power system is little bit vast. that is true. படிக்கிறதுக்கு கொஞ்சம் நிறைய இருக்க மாதிரி ஃபீல் ஆகும். and one more thing, அதுல எதுவுமே காம்ப்ளெக்சிட்டி இருக்காது. there is no big derivation, there are no big complex things to understand. just to go through all the concepts clearly with the passions, you will understand the whole subject. That's all. Then with the help of circuit theory, we can crack all questions. That is the beauty of power system. Let us see. Where is the pen? Yes. Let me draw the network first here. So that is the given network. Impedance, and then they given the capacitor, and then they are given one more inductor. Yes sir. So this is the given transmission line. Am I right sir? Yes. If you observe this, at a point P1 already voltage is given. This is point P1 and given it is 1 per unit at an angle of 0 degree. So I can say at P1 the value of Vp1 equal to 1 at an angle of 0 degree. And if you observe the network carefully, they had given the current value also. What is the value of current? Current value is given as 1 per unit. So magnitude of the current is 1 per unit. Current also given. First, let us see. This value is J 0.1 per unit. Yes, sir. Capacitor minus J 0.15 per unit. Next, for this inductor, J 0.1 per unit. Now, let us catch the voltage at this point. Next, this is called as, we are calling it as point P2, right? For that, see, we know the voltage at this point, that is 1 at an angle of 0. Can you find out the voltage at this inductor? Very simple. So the voltage drop across the inductor will become, it is the product of what? Inductive reactance and current. So 1 into 0.1 will become J 0.1 per unit voltage. That is the voltage drop across the inductance. Now what is the voltage? Vp2. Sir, listen. First there is a inductor. Correct? Yes, sir. இங்க எவ்வளவு voltage இருக்கு? 1 at an angle of 0 இருக்கு. இதுல எவ்வளவு voltage drop ஆயிருக்கு? J 0.1. 1 at an angle of 0 will be equal to 1 only. So now I would like to know the voltage at this point. எப்படி find பண்ணுவீங்க? Total voltage minus the drop here. அப்ப இங்க என்ன வரும்? The value of Vp2 can be written as net voltage minus drop J 0.1. That is the value of Vp2. So we found the value of Vp2 also at P2. Next, at P2, the value of Vp2 equal to 1 minus J 0.1. Next, can you please find out the voltage drop across the capacitor, because next point is P3. We have to find out the voltage at this point, Vp3. For that, next we need to know the voltage drop across the capacitor also. What is the voltage drop across the capacitor? Current value is 1 per unit. 1 into minus J 0.5. So the voltage drop will become minus J 0.15. Already you know the voltage C. At P2, this is the capacitor. At P2, what I am having? 1 minus J 0.1. Here minus J 0.15 we are having. Now I would like to know the voltage at this point, that is Vp3. How will you find? Once again, voltage available at this point minus voltage available at this point. So 1 minus J 0 point minus, already in the expression itself, minus J 0.15 we have. So it will become 1 minus J 0.1. Minus into minus will become plus J 0.15. If you add this to expression, it will become 1 plus J 0.05. I hope I am correct. So the value of Vp3 at P3, the value of Vp3 will become 1 plus J 0.05. That is Vp3. Now let us catch the last voltage, that is Vp4 at point P4. For that, we know the voltage at P3. Yes, sir. From that, again there is one more inductor. See how simple. I told you, na, very basics of circuit theory, but they have given for gate, that is from the power system. So here if you observe at the point P3, what is the voltage that we got? 1 plus J 0.05. Now what is the voltage drop across this inductor? Current through the inductor is 1 per unit and the reactance value is J 0.1. So product of 1 into J 0.1 will become J 0.1 only. Now what is the voltage at this point? Vp4. If you want to know the value of Vp4, what you must do? You have to, 1 minute, I will delete these things. I don't have space. Okay, sir. Now what we can do is, if you want to know the value of Vp4 equal to total voltage available at this point, that is 1 plus J 0.05 minus the voltage, that is J 0.1. J 0.1. Now what you need to do? Just 1 minute, guys. Okay, just to do the subtraction. If you subtract this value, again 0.1 minus J 0. Okay, it will become 1 minus J 0.05. That's half of this value, right? So that is the value of Vp4. So finally we got the value of Vp4 also at point P4. Vp4 become 1 minus J 0.05. Now among these all values, what you have to find? You have to find out the maximum voltage. What is the maximum voltage here? At point 1 we have only 1. At point 2 I have 1 minus J 0.1. At point 2 we have 1 plus J 0.5. At point P4 we have 1 minus J 0.5. If you compare all these values, addition see there, here we have only 1. Here we have 1 minus J 0.1. Whether it is real or imaginary doesn't matter, but it is less value. Here also we have minus. Which quantity is having plus? 1 plus J 0.5 is, just to compare the rectangular values, right? Out of these 4, the highest value is Vp3. So the maximum voltage will be available at point P3. What is the correct answer? Option C is the correct answer. Okay. Sir, don't calculate the magnitude. If you calculate the magnitude, you may have the little bit confusion here. Okay. And you magnitude calculate பண்ணும்போது என்ன ஆகும் அப்படினா மைனஸ்லாம் என்ன ஆயிடும் பிளஸ் ஆயிடும். அப்ப என்ன ஆகும்னா 2 பாயிண்ட்ல ஒரே வேல்யூ வர மாதிரி வரும். That will be confuse you. That's why I am suggesting you just to go with the rectangular values. Okay, as of now, just for understanding purpose. இந்த கொஸ்டின்ல நம்ம magnitude வச்சு ஆன்சர் பண்ண முடியாது. Okay, let us go with the next question. Next, what it was given? A transmission line is having equal voltages at two ends, maintained constant by two sources. Wow. Next, a third source is to be provided to maintain the constant voltage equal to the end voltages at either midpoint of the line or 75% of the distance from the sending end. Then the maximum power transfer capability of this line in original case and the other two cases respectively will be in the following ratios. Very beautiful question. And while going through the question, one thing I would like to clearly tell you. இப்போ நீங்க இந்த கொஸ்டினை பார்த்தோன்னே என்ன திங்க் பண்ணுவீங்க? சார் கொஸ்டின் ரொம்ப பெருசா இருக்கு, கண்டிப்பா கொஸ்டின் வந்து டஃபா தான் இருக்கும். இந்த மைண்ட் செட் வந்து நிறைய பேருக்கு இருக்கும், ரைட்? தட் இஸ் ராங். மெனி டைம்ஸ் ஐ ஹவ் ரிப்பீட்டட். எனிவே, அவங்க என்ன சொல்லியிருக்காங்க அப்படின்னா, there is a transmission line. Okay, first என்ன பண்றாங்க அப்படின்னா, with the help of two different sources, transmission line ஓட sending and receiving endலயும் by connecting two sources, they are maintaining the value of sending end voltage as equal to receiving end voltage. அடுத்து என்ன பண்றாங்க அப்படின்னா, in order to suppose transmission line ஏதாச்சும் ப்ராப்ளம் வந்தா கூட இந்த voltage வேல்யூ வந்து கண்டினியூஸா ஈக்குவலாவே இருக்கணும் அப்படின்றதால from this there are two cases. இது first case. And then second case என்ன பண்றாங்க அப்படின்னா, exactly at the midpoint they are connecting one more source. They are connecting one more source. Exactly the midpoint in the sense the distance will be off. அப்ப reactance என்ன ஆகும்? Let us say the net reactance of the transmission line will be x. In this case we are connecting the source at the midpoint x by 2 distance. Reactance will become what? Half of the transmission line reactance. ஏன்னா midpointல கனெக்ட் பண்றீங்களா, அப்ப half என்ன வரும்? x by 2. Either there are two cases கொடுக்குறாங்க. In order to maintain this sending end voltage as equal to receiving end voltage, we are connecting one more source at the midpoint. One more source at the midpoint, either at midpoint or midpointல connect பண்ணலாம். அப்படி இல்ல அப்படின்னா 75% of the distance அப்படின்னா reactance also will be reduced by 75%. 75% means 3 by 4 times of x. அப்படி இல்லனா இங்க நம்ம கனெக்ட் பண்ணிக்கலாம். சென்டிங் எண்ட்ல இருந்து 75% of the distance, observe the question carefully, 75% of the distance from the sending end அப்படி அவங்க தான் கொடுத்திருக்காங்க. So in order to make the value of sending end voltage as equal to receiving end voltage, அப்ப நம்ம என்ன பண்ணிக்கலாம், இங்க இருந்து 75% of the distanceல வந்து நீங்க reactance, I mean ஒரு source வந்து கனெக்ட் பண்ணிக்கலாம், such that we can maintain the value of sending end voltage as equal to receiving end voltage அப்படின்னு கொடுத்திருக்காங்க. There are three cases now. அப்ப இந்த three casesல வந்து maximum power transfer ஓட ரேஷியோ வந்து என்னென்ன மாதிரி இருக்கும் அப்படிங்கறத question சால்வ் பண்ணலாமா? So the maximum power transfer capability, case number 1. First of all, for real power, the formula can be written as sending end voltage into receiving end voltage divided by reactance x into sin delta. First formula. From this formula can be written as P is equal to P max into sin delta. Correct? Yes sir, we are correct. From this I can say the value of maximum power can be written as sending end voltage into receiving end voltage divided by reactance x. That is the general formula to obtain the maximum power in our transmission line. Not only transmission line, anywhere this is the general formula except salient pole synchronous machine. Okay sir. Now in this case, case number 1, what will be the total reactance? Only x from the sending end. So that is the case number 1, maximum power transfer capability. Case number 2 என்ன வரும்? P max 2 equal to second case, sending end voltage into receiving end voltage divided by reactance will be, now we are connecting one source exactly at the midpoint. Now what will happen? This up to midpoint only, now we have to calculate the real power transfer from here to here, such that what will happen? This resultant connection will maintain the value of receiving end voltage and sending end voltage as equal. அப்ப நம்ம இங்க இருந்து டிரான்ஸ்ஃபர் ஆகிற பவர் கேப்பபிலிட்டி கால்குலேட் பண்ணோம் அப்படின்னா up to this point we have to calculate. அப்ப reactance என்ன வரும்? In this case reactance will become x by 2, or I can say it will be twice of Vs into Vr divided by x. This Vs into Vr by x is what? That is P max 1. So I can say this is 2 times of P max 1 second power. So we got the relation for P max 1 and P max 2. Yes sir. Now let us go through the P max 3. P max 3 என்ன ஆகும் பாருங்க, that is 3 by 4 times of x. So the value of P max 3 can be written as sending end voltage into receiving end voltage divided by reactance will be 75%. So it can be written as 4 by 3 times of Vs into Vr divided by x. That is nothing but P max 1. Finally, we found the relation for all power. Finally, what relation we found? That is Pmax 1 we got. Pmax 2 we know the relation. Pmax 3 also we know the relation. Up answer it can be written as Pmax 1 is to Pmax 2 நம்ம என்ன பண்ணிக்கலாம் 2 times of Pmax 1. Pmax 3 can be written as 4 by 3 times of Pmax 1. So the ratio is 1 is to 2 is to 4 by 3. 1 is to 2 is to 4 by 3. 4 by 3 நம்ம வேற எப்படி எழுதலாம்? It can also be written as 1 divided by 3 by 4. It can also be written as 1 divided by 0.75. ஏன்னா உங்க ஆப்ஷன்ல அந்த மாதிரி கொடுத்திருக்காங்க. I am not doing anything. So the correct answer is 1 is to 2 is to 1 divided by 0.75. What is the correct answer? Option B. I hope option B only. Yes, option B is the correct answer. 1 is to 2 is to 1 divided by 0.75. Beautiful question, right? And it is very simple too. You have to understand how to crack the question. That's all. Okay, sir. Let us go ahead with the next question. For a fixed receiving end and sending end voltage of the transmission line, what will be the locus of the constant power? Anyway, this is not our syllabus, but I can just suggest you. நம்ம என்ன பண்ணலாம்னா locus வரையணும் நம்ம. For a fixed power can be written as 1 minute. I will change the color. This is not your syllabus, guys. You can skip it. So Vs into Vr divided by reactance X into sin del. Okay, na? So now what they are doing? They are maintaining this receiving and sending end voltage as constant. Power also constant. They only told constant power locus. So it means they are just simply from this what I can say X equal to sin delta. These are all the variable quantity. Sin delta will follow what? It is circle 0 to 180 positive off, 180 to 360 negative off. Either you will circle you will get the complete circle. So it will follow circle. That's all. The correct answer is option D. But you can skip it, as I told you, this is not in your syllabus. Okay, next. For the system shown below, SD1 and SD2 are the complex power. Complex power. 1 minute, guys. I think this question is shifted inside, right? Okay, complex power demands. Let me read the question. I hope. For the system shown below, SD1 and SD2 are complex power demands at bus 1 and bus 2 respectively, right? If the value of V2 equal to 1 per unit and the value of VAR, right, rating of that is the reactive power rating, this is of the capacitor QG2 at connected bus 2 is dash. Question என்ன கேட்டிருக்காங்கன்னா simply the value of QG2 is what அவ்வளவுதான். Instead of reading all these things, just we can go through the diagram, because in diagram all the data is already available. Just we need to catch the value of QG2. 1 minute, let us remove all the black things. Yes. So observe the diagram carefully. First collect the data from the diagram. Enna data கொடுத்திருக்காங்க? Given it is value voltage at the bus 1 is given as 1 per unit. At the bus 2 voltage is not known, right? Okay, sir. Next, impedance Z is clearly given, that is J 0.5 per unit. Yes, sir. That is also clearly known. Next, what it was given? Power consumed by the loads in both sides, it was clearly given as 1 per unit. I think voltage V2 is given in the data. Question la கொடுத்திருக்காங்க பாருங்க 1 per unit. That is also 1 per unit. Okay. Okay, sir. Everything is clear. Now we have to find out the value of QG2. Generally, இந்த capacitor வந்து எதுக்காக கனெக்ட் பண்ணுவாங்க அப்படின்னா, let me clearly tell you. நம்ம ஏற்கனவே சொல்லிருப்போம் இல்லையா, நம்ம ப்ரீவியஸ்ல ப்ராப்ளம் சால்வ் பண்ணும்போது கூட நான் சொல்லியிருந்தேன். கெபாசிட்டர் அப்படிங்கிறது காம்பன்சேட்டர். ஆக்சுவலா இது என்ன பண்ணும் அப்படின்னா லாகிங் ரியாக்டிவ் பவர் டெலிவரி பண்ணும். கெபாசிட்டர் வில் டெலிவர் லாகிங் ரியாக்டிவ் பவர். எப்பப்பெல்லாம் வந்து லோட் சைட்ல வந்து லாகிங் ரியாக்டிவ் பவரோட டிமாண்ட் வந்து அதிகமாகுதோ, இண்டக்டிவ் லோட்ஸ் வந்து என்ன பண்ணும், லாகிங் ரியாக்டிவ் பவரை அப்சர்வ் பண்ணும். Inductor will absorb lagging reactive power. Inductor இது அப்சர்வ் பண்ணும். இண்டக்டர் கெபாசிட்டர் வந்து அதை டெலிவரி பண்ணும். அப்ப நம்ம என்ன பண்ணிக்கலாம் அப்படின்னா லோட் சைட்ல வந்து இண்டக்டர் வந்து எவ்வளவு டிமாண்ட் கொடுக்குதோ, எவ்வளவு கேக்குதோ லாகிங் ரியாக்டிவ் பவர், அதை கெபாசிட்டர் வச்சு அப்படியே நம்ம சப்ளை பண்ணிட்டோம் அப்படின்னா ஜெனரேட்டர்ல இருந்து நம்ம என்ன பண்ண தேவையில்ல, ரியாக்டிவ் பவரை கொண்டு வர தேவையில்ல லோடுக்கு. such that we can avoid the losses in the transmission line. In order to minimize the losses in the transmission line, we are doing some kind of compensation at the receiving end directly, such that what will happen, losses will be minimized as low as possible in our transmission line. That's all. இதுக்காக தான் நம்ம இதை யூஸ் பண்றோம். இப்போ இந்த கெப்பாசிட்டர் வந்து என்ன பண்ணும் அப்படின்னா ரிசீவிங் எண்ட்ல இருக்க லோடு வந்து எவ்வளவு ரியாக்டிவ் பவர் டிமாண்ட் பண்ணிருக்கோ அந்த ரியாக்டிவ் பவரை இதுவே சப்ளை பண்ணிடும். அவ்வளவுதான், அதான் இதோட வேலை ஜென்ரலாவே. நம்மளோட டார்கெட் என்ன அப்படின்னா இந்த டிரான்ஸ்மிஷன் லைனோட ரிசீவிங் எண்ட் வந்து எவ்வளவு ரியாக்டிவ் பவர் வந்து கன்சியூம் பண்ணிட்டு இருக்குன்னு பார்க்கணும். அதை கண்டுபிடிச்சிட்டோம் அப்படின்னா அதே பவர் தான் இந்த கெப்பாசிட்டர் வந்து சப்ளை பண்ணிருக்கும். தட்ஸ் ஆல். ஜென்ரலாவே தட் இஸ் தி கேஸ். இப்போ சால்வ் பண்ணலாமா? எப்படி சார் இதை கால்குலேட் பண்றது? ரொம்ப சிம்பிளா ரிசீவிங் எண்ட்ல தான் இப்போ நம்ம எல்லாத்த பத்தியுமே பேச போறோம். ரிசீவிங் எண்ட்ல தான் கெப்பாசிட்டர் கனெக்ட் பண்ணிருக்காங்க. Now tell me what is the real power formula and reactive power formula at the receiving end? Very simple. That is sending end voltage into receiving end voltage divided by reactance X into sin delta. This is reactance X that denotes reactance of the transmission line. This is reactance of transmission line. That is very important. That is reactance of the transmission line. Okay sir, that is over. First case. What is the formula to obtain the reactive power? I hope you all can remember sending end voltage into receiving end voltage divided by reactance X into cos delta minus receiving end voltage VR square divided by X. Yes. அப்ப இந்த ரியாக்டிவ் பவர் தான் இப்ப நம்ம கால்குலேட் பண்ண போறோம். இதுதான் வந்து ரியாக்டிவ் பவர் கன்சியூம்டு பை தி லோட். இந்த பவரை கால்குலேட் பண்ணிட்டீங்கன்னா இந்த லோட் இந்த ரியாக்டிவ் பவர் யார் இப்ப சப்ளை பண்ண போறா? கெபாசிட்டர். So that is the answer for the capacitor. So we have to catch up the value of this Q. That's all. Fine. இப்போ இந்த வேல்யூ ரியாக்டிவ் பவர் நம்ம கால்குலேட் பண்ணோம் அப்படின்னா நமக்கு என்னென்ன பாராமீட்டர்லாம் தேவைன்னு ஃபர்ஸ்ட் அப்சர்வ் பண்ணுங்க. சென்டிங் எண்ட் வோல்டேஜ் தேவை, கொடுத்துட்டாங்க 1 per unit. ரிசீவிங் எண்ட் வோல்டேஜ் தேவை, கொடுத்துட்டாங்க 1 per unit. ரியாக்டன்ஸ் எக்ஸ் தேவை, கொடுத்தாச்சு 1 per unit. Sorry, J reactance only X is given as J 0.5. That is magnitude equal to 0.5. அதையும் கொடுத்தாச்சு. Next, delta, that is the phase angle difference between del 1 minus del 2. அதாவது ரெண்டு பஸ்ஸஸ் இருக்கு இல்லையா? இங்க we are having two buses, bus 1 and bus 2. bus 1 ல இருந்து bus 2 இது ரெண்டுத்துக்கும் சேர்ந்த net phase angle difference தான் இங்க delta. So you have to catch out the value of delta. டைரக்டா இங்க ஒரு வேல்யூ மட்டும் 0 ன்னு கொடுத்திருக்காங்க. நீங்க அப்படியே எடுத்து சப்ஸ்டிட் பண்ண கூடாது. செகண்ட் வோல்டேஜ்க்கு கொடுக்கல. So we cannot guess the value of delta. That is very important. We have to identify. And then receiving end voltage reactance VR, that is 1. Reactance as usual, that is given as magnitude is 0.5. We can substitute. So in order to catch up this reactance only, the one and only unknown data is delta only. We have to calculate the net value of this delta. அப்ப இது எங்க சார் கால்குலேட் பண்றது? Let us see. To calculate in the net value இப்ப நம்ம calculate பண்ணோம் அப்படின்னா go back to the real power. That is very important and famous model. இந்த question வந்து ரொம்ப small questionங்க. ஆனா இது repeated எல்லா எக்ஸாம்லயும் கேட்டே இருப்பாங்க. Only you have to remember these two formulas. That's all. You can easily crack. Okay sir. Go back to the receiving end power. Sin delta. இங்க இருந்து delta calculate பண்ண முடியுமான்னு பாருங்க. See, reactance value is known. That is 0.5 transmission line reactance. Sending end voltage 1, receiving end voltage is 1, and that is real power. If you observe the question carefully, அவங்க என்ன சொல்லிருக்காங்கன்னா காம்ப்ளெக்ஸ் பவர் டேட்டா அங்க கொடுத்திருக்காங்க. See, complex power க்கு இங்க வேல்யூ எவ்வளவு கொடுத்திருக்காங்க? That is 1 per unit. The value of the complex power is given as what? 1 per unit. Right? So from this what I can say, the real power consumed by the load is going to be 1 only. Directly we can say, because it is not the combination of real and imaginary power. அவங்க எதுவுமே ஆங்கிளும் கொடுக்கல, directly 1 per unit only கொடுத்திருக்காங்க. Right? So 1 per unit means what I can say, real power equal to 1 per unit by default. 100% we can consume. We can assume in per unit. So let us substitute by default. See, if there is no data about the real power, by default you can assume that value is what? 1 per unit. That is 100% real power consumption. That's all. So let us catch up. This அப்படியே substitute பண்ணீங்கன்னா what will you get now? This is 1. So this is going to be 1 equal to 1 into 1 upon 0.5 into sin delta. From this, sir, real power வந்து mostly questionல கொடுத்துருவாங்க. கொடுக்கலனா 1 assume பண்ணிக்கோங்க. That's all. That is 100%. In per unit that will be 1. That's all. Okay. Fine sir. இப்போ நம்ம என்ன பண்ண போறோம்? இப்போ real power அப்ப என்ன வரும்? Real power equal to sin delta. From this you can calculate the value of sin delta or delta. Directly you can calculate delta. 0.5 அப்படினா 1 by 2 ன்னு சொல்லலாமா? So delta equal to sin inverse of 1 by 2. I hope that will be equal to 30 degree. We all know. So the value of delta equal to 30 degree. Finally we got the value of delta. Now calculate the reactive power. That's all. Question is over. So you know the value of voltages. That is 1 into 1 divided by 0.5. That will be 2. 2 into cos 30 minus 1 divided by, that is 1 square divided by 0.5. That is also 2. Actually, what we obtain finally 2 into what is the value of cos 30? Cos 30 will be root 3 divided by 2 minus 1, right? So it will be 2 into it will be 0.8666 minus 1. I hope I'm correct, right? So we are going in a correct flow. So it will be what? So 0.866 minus 1 putting, finally you will get 1 minute. I will drop the answer. It will be 1 minus 0. I'm getting negative answer into 2. So it will be 0 point, if I multiply it, I'll get 2.6. Yes. See, that is the reactive power consumed by the load. Now what that QG2 will do, if it is consuming Q oda value என்ன வருது அப்படின்னா -0.268 வந்திருக்கு அப்படின்னா, what about the value of QG2? நான் என்ன சொன்னேன், இது எவ்வளவு டிமாண்ட் பண்ணதோ அந்த பவரை இது சப்ளை பண்ணிடும் ஃபர்ஸ்ட் ஆஃப் ஆல். ஓகே, அப்ப நம்ம என்ன பண்ணலாம், இது அப்சர்வ் பண்ற பவர், லோட் அப்சர்வ் பண்ற பவரையும் ஜெனரேட்டர் டெலிவரி பண்ற பவரையும் கூட்டினா நெட் வேல்யூ 0 வரணும். Why? Because observation equal to delivery. அப்ப நெட் பவர் will become 0 னா, அப்ப இதோட வேல்யூ இங்க சப்ஸ்டிட் பண்ணுங்க. It will be minus 0.268 plus QG2 equal to 0. From this I can say the value of QG2 equal to 0.268. What I told you, load எவ்வளவு reactive power consume பண்ணுதோ அந்த power இந்த generator QG2 supply பண்ணிடும், capacitor supply பண்ணிடும்னு சொன்னேன். அப்ப load consume பண்ற power யார் டெலிவரி பண்றா, QG2 தான் டெலிவரி பண்ணுது. அப்ப அதோட வேல்யூ வந்து -2.68 வருது அப்படி, சாரி -0.268 வருது அப்படின்னா இதோட வேல்யூ வந்து +0268 வரணும். அப்பதான் நெட் வேல்யூ என்ன வந்துரும், இங்க 0 ஆயிடும். ரிசல்டன்ட்ல reactive power என்ன ஆகாது, சென்டிங் எண்ட்ல இருந்து வராது. This generator, the capacitor itself will supply the reactive power. I hope you all have understand. That is very important. Especially observe the formula. நான் எப்படி அப்ளை பண்ணேன்னு பாருங்க, because இதை வச்சு நிறைய different question கேட்பாங்க. If you remember these two formula, you can crack all questions. Okay, let us go ahead with the next question. Okay, the question is what? Two networks are connected in cascade as shown in the figure. Of course, in the model நம்ம ஏற்கனவே solve பண்ணோம் இல்லையா? With the usual notations, equivalent ABCD constant is given as usual. என்ன சொல்றாங்க அப்படின்னா, with the usual notations the ABCD equivalent constants are obtained. Given that the value of C equal to how much is 0.02545 சொல்றாங்க. Then the value of Z2 is dash. First of all, sir, network is given as what? 1 minute, let me draw. Okay, sir. Let us assume this is impedance Z1. Okay, let me keep one more impedance. This is Z2. Let us calculate separately. First, அவங்க தான் क्वेश्चनல பிரேக் பண்ணிட்டாங்களே, அது ரெண்டா பிரேக் பண்ணிட்டாங்க. எனிவே நம்ம சிம்பிளா சால்வ் பண்ணிடலாம், பட் உங்களோட அண்டர்ஸ்டாண்டிங்காக நான் ஃபுல்லா டெரைவ் பண்றேன். Let us take the first network. இந்த impedance Z1 மட்டும் தனியா எடுத்துக்கங்க. Calculate the value of ABCD parameter for this impedance. When we have only Z1, what we will obtain? The ABCD parameter sending end voltage equal to A times of receiving end voltage plus B times of receiving end current. See, நீங்க திரும்ப இத பார்த்தாதான் உங்களுக்கு பிராக்டிஸ் ஆகணும். again I'm doing, so you can also do it by yourself. It is very simple question. Fine sir, இப்போ நீங்க எப்படி கால்குலேட் பண்ணுவீங்க? While calculating A and C, we should make the value of IR as 0. இப்போ receiving end current வந்து நம்ம 0 ஆக்கிட்டோம் அப்படின்னா that will be open circuited. அப்ப என்ன வரும்? If it is open circuited, then this current flow into the transmission line will become 0 ampere. Correct? So அப்ப அந்த கேஸ்ல என்ன வரும்? I can say sending end voltage equal to, then there will be no drop. There will be no drop here because 0 into Z1 will become 0 voltage. அப்ப sending endல எவ்வளவு voltage இருக்கோ அது அப்படியே receiving endக்கு transmit ஆயிடும். So sending end voltage equal to receiving end voltage. So I can say the value of A equal to 1 from here. Because we know sending end voltage equal to A times of VR. When Vs and VR will become equal, it by default it denotes that the value of A equal to 1. Similarly, sending end current equal to, since open circuit, right, sending end current value 0 ஆயிடுச்சு. ஏன்னா லைன் வந்து ஒரே ஒரு லைன், அது ஓபன் சர்க்யூட் பண்ணிட்டீங்க, நீங்க receiving end ஓபன் சர்க்யூட் பண்ணிருக்கீங்க. அப்ப sending end current என்ன ஆயிடும்? 0 ஆயிடும், since both are in series. அப்ப sending end current 0 அப்படின்னா C equal to 0. Yes sir. So what we found? The value of A we found, that is 1, and the value of C also we found, that is 0. Next, B and D calculate பண்ணும்போது receiving end short circuit பண்ணணும். So we have the impedance, it will be short circuited, Z1. Observe how I am doing. உங்களுக்கு இதெல்லாம் லேர்ன் பண்ணிக்கணும்ன்றதா தான் நான் பண்ணிட்டு இருக்கேன், right? So sending end current will become equal to receiving end current in this case. Receiving end short circuit data, if you apply KVL, what will you obtain? If you apply KVL, anyway, I need the expression for sending, sorry, first sending end voltage. This is sending end voltage, right? Sending end voltage equal to the voltage drop across the impedance. I can write it as IR into Z1. In terms of receiving end current தான் நீங்க எழுதணும், because எனக்கு expression எதுல வேணும், in terms of receiving end. So from this what I can observe, B equal to Z1, because VS equal to B into IR, whereas the value of B equal to Z1. So we found the value of B also, value of B equal to Z1. Okay, let us catch. And we also know sending end current equal to receiving end current in this case. See that line is completely closed, sending end current equal to receiving end. So D value equal to 1. We found the value of ABCD. Yes sir, substitute here. So the value of A equal to 1, value of B equal to Z1, value of C equal to 0, value of D equal to what? D equal to 1. That is the first network. இப்போ second network, இந்த network நம்ம value calculate பண்ணோம். Proceed பண்ணலாமா? Yes. So 1 Z1 0 1. So what we found is 1 Z1 0 1. One network is completed. Second network, if I will consider only this Z2. இப்போ இதுக்கு மட்டும் calculate பண்ணலாமா? நம்ம already இதுக்கு calculate பண்ணியிருக்கோம், கரெக்ட்டா? முன்னாடி நம்ம இத பண்ணோம். So this is Z2. Let us see once again from this is sending end voltage. From here we are going to pass the sending end current. This is receiving end current. Here we are going to consider receiving end voltage. Sir, why I am not considering the minus? ABCD parameter la namak network la enna equation varum, sending end voltage equal to A times of receiving end voltage minus B times of receiving end current. That is the actual expression, but I have reversed the direction of current, so I am putting plus. Sending end current equal to C times of receiving end voltage plus D times of receiving end current. Second network calculate பண்ணலாமா? As usual, first make the value of IR equal to 0. So receiving end will be open circuited. அப்ப receiving end open circuit ஆயிடுச்சுனா let us apply KVL. அப்ப இங்க என்ன வரும், sending end voltage VS equal to I can say the value IS into Z2, IS into Z2 first, right? But what is the conclusion here? When there will be no, if இங்க ஏதாச்சும் impedance drop இருக்கா, I can simply say VS equal to this VS IS into Z2 simply equal to what? VR. Whatever the voltage that is there here, that is the voltage that we are measuring across these 2 points. So I can say that is equal to VR. When VS and VR will become equal, from this we can say once again the value of A become 1. Yes sir. Similarly, IR value 0 இருக்கும்போது we can also calculate C. அப்ப என்ன பண்ணலாம்? We know since the value of receiving end current is 0. அப்ப நம்ம என்ன பண்ணலாம்? Just now I have written the expression. So அப்ப என்ன பண்ணிக்கலாம்னா IS equal to, நம்ம இங்க இப்பதான் expression எழுதணும் இல்லையா? See there. IS into Z2 equal to VR னு சொன்னோம்னா, from this what I can say, the value of IS equal to VR divided by Z2 னு எழுதலாமா? So that is 1 by Z2 into VR. This is what? IS equal to C into VR. C oda value 1 by Z2. So next what we found is value of A is 1. Value of C is 1 divided by Z2. Let us catch up the remaining value. Again, receiving end இப்ப நீங்க short circuit பண்ண போறீங்க. Receiving end short circuit பண்ணிட்டீங்கன்னா impedance will become useless. Why? When line is short circuited across the parallel impedance, the net value will become 0. அப்ப டோட்டலாவே என்ன வரும்? ஒரே ஒரு short circuit line தான் வரும், like this. So let us calculate. 1 minute guys, I think I have removed all the values. This is 1 Z1 0 1. I hope I am correct. Next, here we found 2 parameter 1 upon Z1. Let us calculate remaining 2 also. அப்ப நம்ம short circuit பண்ணிட்டோம் அப்படின்னா what you will obtain? Sending end voltage equal to C times of receiving end current. That is what you will get. Sending end current equal to D times of receiving end current. இது மட்டும் தான் நமக்கு தெரியும். அப்ப இங்க என்ன ஆகும்? Sending end current equal to receiving end current now. Yes sir. So I can say D equal to 1 because both are equal. What about C? See, this is sending end voltage. Absolutely true sir. Since line is short circuited line, in short circuited line voltage will be 0. So what I can say, sending end voltage will be 0. அப்ப C oda value என்ன வரும்? C equal to 0 sir. Finally what we have understood, C value is 0, D value is 1. So what is the total impedance now? ரெண்டுத்தையும் multiple பண்ணுங்க. If you multiply this net impedance, that will become 1 into 1, it will be 1 plus Z1 plus sorry, Z1 into 1 by Z1. 1 into 1 plus Z1 into 1 by Z1. It will become 1. Next here 1 into 0, it will be 0 plus Z1, it will become Z1. Similarly, it will be 0 plus 1 by Z1. Next 0 plus 1 into 1 will become 1. So finally what we are going to obtain here, 2 Z1 1 divided by Z1 1. Don't think that we have solved a very big question. For your understanding, as a faculty I have to spend a long time, then only you will understand this subject. As a student you have to raise up your speed. You should solve as early as possible. இப்போ நீங்க practice பண்ணிட்டீங்களா, டக்கு டக்கு டக்குன்னு brainலயே போடணும். Because I cannot say everything in brain, definitely you will be messed up. Okay, fine sir. Finally, this is what we found. Questionல அவங்க என்ன சொல்லிருந்தாங்க, இந்த நெட்வொர்க்கோட டோட்டல் ABCD பாராமீட்டர்ல வந்து அவங்க ஒரே ஒரு பாராமீட்டர் மட்டும் கொடுத்திருக்காங்க. இந்த நெட்வொர்க்கோட டோட்டல் நெட்வொர்க்கோட பாராமீட்டர்ல C ஓட வேல்யூ மட்டும் கொடுத்திருக்காங்க. நம்ம எப்படி எழுதுவோம், this is A B C. இந்த நெட்வொர்க்கோட டோட்டல் ABCD பாராமீட்டர்ல இந்த C ஓட வேல்யூ மட்டும் கொடுத்திருக்காங்க. How much it is? 0.025. இப்போ நம்ம அதோட வேல்யூ தான் கால்குலேட் பண்ணியிருக்கோம். நம்ம given network reduce பண்ணி அந்த C ஓட வேல்யூ கால்குலேட் பண்ணிருக்கோம். C equal to 1 upon Z1. So from this Z1 equal to 1 by C. C ஓட வேல்யூ எவ்வளோ, 1 divided by 0.025 at an angle of 45 degree. அந்த 45 மேல எடுத்துட்டு வந்துருங்க. 1 divided by 0.025 will become 40 at an angle of minus 45 degree. So the simplest answer for this question is option C, 40 at an angle of minus 45 degree. Okay. So that is how you have to crack C. எக்ஸாம்ல வந்து கொஸ்டின் எப்பவுமே ஈஸியா இருக்கும். ஆனா அவங்க என்ன பண்ணுவாங்கன்னா, இப்ப பாருங்க இந்த நெட்வொர்க் எவ்வளவு ஈஸியான ஒரு நெட்வொர்க்கா, உங்களை வந்து பயமுறுத்தணும். அவங்களோட வேலையை வந்து அந்த கொஸ்டினை பார்த்த உடனே நீங்க பயந்து போகணும். ஆனா கொஸ்டின் ரொம்ப ஈஸியா இருக்கும். அந்த டைமிங்குள்ள சால்வ் பண்ற மாதிரி தான் டேட்டா கொடுத்துருப்பாங்க. யூஸ்வலாவே என்ன ஆகும் அப்படின்னா, எல்லா ஸ்டூடெண்ட்டுக்கும் ஒரு ஃபியர் இருக்கும், கொஸ்டின் பெருசா இருந்தா ஆன்சர் வராது, கண்டிப்பா அது காம்ப்ளிகேட்டடா தான் இருக்கும் அப்படின்ட்டு. அந்த ஃபியரை கொண்டு வந்தாங்கன்னா ஆட்டோமேட்டிக்கா என்ன ஆகும், காம்படிட்டர்ஸ் வந்து ரெடியூஸ் பண்ண முடியும். நிறைய பேர் வந்து எக்ஸாம்ல வந்து ஃபெயில் ஆகணும். ஏன்னா அவங்களால என்ன பண்ண முடியாதுன்னா, எல்லாரையும் ஷார்ட் லிஸ்ட் பண்ணி ஜாப் கொடுக்க முடியாது, இல்ல சீட் கொடுக்க முடியாது காலேஜஸ்ல. அதுக்காக இந்த மாதிரி கொஸ்டின்ஸ் எல்லாம் எடுப்பாங்க. ஸோ பி பேஷன் வைல் ரீடிங் தி கொஸ்டின். அது எவ்வளவு பெரிய கொஸ்டினா இருந்தாலும் பரவாயில்ல, ஸ்ட்ராங்லி பிலீவ் தட் கொஸ்டின்ஸ் ஆர் ஈஸி. அது நமக்கு தெரிஞ்ச கான்செப்ட் தான்றதை பிலீவ் பண்ணி சால்வ் பண்ணுங்க. அந்த மாதிரி சால்வ் பண்ணும்போது ஆட்டோமேட்டிக்கா இந்த மாதிரி பயப்படுற ஸ்டூடெண்ட்ஸ் இருக்காங்கல்ல, அவங்களோட ரேங்க் எல்லாம் பின்னாடி போயிடும் உங்களோட ரேங்கை விட. ஸோ ஷுட் ட்ரை டு கெட் இட், கீப் இட் இன் யுவர் மைண்ட். Whenever you are facing very big questions or very big network, strongly believe that question is very easy. We will be able to solve that. Go to the next one. Next question is, the insulation resistance is clearly given. The insulation resistance of a single core cable is 200 mega ohm per kilometer. The insulation resistance of 5 kilometer length is what? First of all, tell me what is the formula to obtain the resistance of the core. Insulation resistance, core resistance will become rho upon 2 pi L into ln of resistance, that is external resistance, radius of the external core divided by radius of the internal core. That is the formula. Actually என்ன பண்ணிருப்பாங்கன்னா, क्वेश्चनல வந்து கிளியரா கொடுத்திருப்பாங்க. இன்டர்னல் ரேடியஸ் வந்து R1 னு கொடுப்பாங்க, எக்ஸ்டர்னல் ரேடியஸ் வந்து R2 னு கொடுப்பாங்க. நீங்க R1 R2 னு படிச்சீங்கன்னா மறந்துடுவீங்க. அதனால தான் நான் எக்ஸ்டர்னல் எழுதுனேன். எக்ஸ்டர்னல்னா யாரு, டோட்டல் ரேடியஸ் R2, இன்டர்னல்னா யாரு, R1. அப்ப அவங்க என்ன பண்ணிருப்பாங்கன்னா, எக்ஸாம்ல வந்து R2 by R1 னு கொடுத்திருப்பாங்க. Okay, fine. Coming back. Now see what is the relation between resistance, insulation resistance and length both are reciprocal to each other. That's all. Resistance is directly proportional to 1 by L. Fine sir. இப்போ நம்ம என்ன பண்ணலாம், கேஸ் நம்பர் 1ல என்ன சொல்லிருக்காங்க, the insulation resistance of the single core cable per kilometer. ஒரு கிலோமீட்டர்ல வந்து 200 mega ohm. So let us write R2 divided by R1 from the above expression. It will become L1 divided by L2. From the second, say the value of R2 will be R1 into L1 divided by L2. First case என்ன சொல்லிருந்தாங்க, R1 வேல்யூ வந்து 200 மெகா ஓம் பர் கிலோமீட்டர், அதாவது 1 கிலோமீட்டர் டிவைடட் பை R2 ஓட வேல்யூ அப்ப 5 கிலோமீட்டருக்கு எவ்வளவு வரும்னு கேக்குறாங்க. So it is in mega ohm. இத கேன்சல் பண்ணீங்கன்னா எவ்வளவு வரும், it will be 40. So the answer is what, 40 mega ohm. Okay, so the correct answer is option A. Okay sir. So let us go with the next question. அடுத்து என்ன கொடுத்திருக்காங்க பாருங்க. Read the question carefully. Consider the three-phase core. Consider three-phase 50 Hz 11 kilovolt cable whose conductors are denoted as RYB in the figure. The intercapacitor C1 between each pair of the conductor is 0.2 microfarad and the capacitance between the each line conductor, line and sheath is 0.4 microfarad. First என்ன சொல்லிருக்காங்க, the interface capacitance between each pair of the conductors, right? Intercore la capacitance கொடுத்துட்டாங்க, that is C1 value is given, that is 0.2 microfarad, right? Clearly given. அதே மாதிரி என்ன பண்ணிருக்காங்க next between the capacitor between the line and the sheath, that is external, sheath ஓட வேல்யூ எவ்வளவு கொடுத்திருக்காங்க 0.4. so this is given as 0.4, this is given as 0.2 microfarad, clearly given. Next the question is, then the per phase charging current is what? First write down the formula to obtain the per phase charging current, later we will discuss about the rest of thing. First of all, per phase charging current, according to Ohm's law, it will be equal to per phase voltage divided by reactance per phase. It will be equal to per phase voltage divided by reactance per phase, can be written as 1 upon omega c. I am not considering the j, I just want magnitude. From this I can say per phase reactance into omega into c. That's all. From this omega can be replaced by 2 pi f. So it can be written as per phase voltage into 2 pi f into c. So this is the formula to obtain the per phase charging current. Okay, fine sir. Very simple. Don't memorize anything. You know basics of network, right? That is enough. We can solve the question. Fine sir. Come back to the circuit now. Circuit la enna kuduthirukanga, or delta network kuduthirukanga. Okay va. நமக்கு என்ன தேவை அப்படின்னா per phase capacitance தான் தேவை. see, இப்போ இந்த क्वेश्चனை கிராக் பண்ணோம் அப்படின்னா என்னென்ன டேட்டா தேவை? per phase voltage 2 pi is constant, frequency 50 Hz already given, capacitor C தெரியாது, per phase voltage தெரியாது, ஆனா line voltage தெரியும். line voltage was clearly given as 11 kilovolt. so from this per phase voltage will be equal to line voltage upon root 3. so I can say the value of per phase voltage will be 11 upon root 3 times of kilovolt. We know the value of per phase voltage now. Then what is the unknown data? The one and only unknown data is capacitor per phase. You have to find out the capacitance per phase. That's all. எப்படி சார் கால்குலேட் பண்றது? இப்போ क्वेश्चन அப்சர்வ் பண்ணுங்க. RYB அப்படிங்கிறது phases. அந்த RYB க்கு நியூட்ரலுக்கு நடுவுல தான் இப்போ நீங்க வேல்யூ வந்து கால்குலேட் பண்ணனும். ஓகே, let me draw. சார் அங்க சர்க்யூட் என்ன கொடுத்திருக்காங்க? இது C2. ஓகேவா? அவுட்டர் ஷீத் வந்து எங்க கனெக்ட் ஆயிருக்கும் அப்படின்னா கிரவுண்ட்ல தான் கனெக்ட் ஆயிருக்கும். ஃபர்ஸ்ட் ஆஃப் ஆல் இங்க என்ன இருக்கு? திஸ் இஸ் R. அடுத்தது here we are considering one more capacitor, I think C1. Here we are considering one more. This is B, that is RB. Next this is one more capacitor. Okay, this is RBY definitely. அடுத்து என்னன்னா இங்க ஒரு capacitor கொடுத்திருக்காங்களா? C2. Definitely that will be connected with the what? Outer sheath. Outer sheath means outer sheath will be connected with the ground only. So this is also will be connected with the ground. This is outer. Inner values will be considered C1, right? Fine sir. Per phase to neutral capacitance தான் இப்போ நமக்கு தேவை. இப்போ நம்ம என்ன பண்ணோம்? ஃபர்ஸ்ட் அப்ப இந்த டெல்டாவை வந்து நீங்க என்னவா மாத்தணும் அப்படின்னா ஸ்டார் கனெக்டட் நெட்வொர்க்கா மாத்தணும். இல்லனா நம்மளால டைரக்டா அதை சால்வ் பண்ண முடியாது. Okay, let me ask you, this is the delta connected network. It is having impedance Z in all phases. Let us take R, B, Y. When all the phases of the delta network is having equal impedance, then its correspondent star connected network can now go. You know how to convert the delta to star. That basic, kindly go through and learn how to do it if you don't know. Okay, when all impedances are equal, while going from delta to star, in star connected network the impedance will be 3 times of the delta connected network. I am writing the answer directly. If you don't know, please learn it because these things are very important. Okay, fine sir. Similarly, ஸ்டார்ல இருந்து நீங்க டெல்டாவுக்கு போறீங்க அப்படின்னா சப்போஸ் ஸ்டார் கனெக்டட் நெட்வொர்க் இஸ் கிவன் சார். இது ஜஸ்ட் நீங்க ஃபார்முலா அப்ளை பண்ணீங்கன்னா உங்களுக்கு வந்துடும். மெமரைஸ்லாம் பண்ண தேவையில்ல. எல்லா இம்பிடன்ஸ் ஈக்குவலா இருந்ததுன்னா டெல்டாவுக்கு இதை நீங்க மாத்தும் போது என்ன ஆகும் அப்படின்னா இம்பிடன்ஸ் will be reduced 3 times when all impedance are equal. That's all. Keep these basics in your mind. It will be helpful. Fine sir. அப்ப டைரக்டா நீங்க என்ன பண்ணிக்கலாம்? இத வந்து டெல்டால இருந்து ஸ்டாருக்கு வந்து கன்வர்ட் பண்ணீங்க அப்படின்னா what you will get, the resultant network you are going to obtain. Here you will get one capacitor, that is R phase, right? இங்க என்ன ஆகும்? இன்னொரு capacitor. அப்படியே ஸ்டார் கனெக்ஷனுக்கு இது மாறும். This is Y phase. There will be one more capacitor that will be connected to sheet. Here there will be one more capacitor. This is B. And one more capacitor that will be connected to sheet. That is C2, external capacitor. இப்போ நம்ம என்ன மாத்திட்டோம்? டெல்டாவை ஸ்டாரா மாத்திட்டோம். This is 3C1. நான் இப்ப தான சொன்னேன் 3 times வந்து capacitor வந்து boost ஆகும் அப்படினு சொல்லிட்டு. Now see that this is also neutral. ஆமா சார். எக்ஸ்டர்னலா this is also neutral. கரெக்ட்டா? Yes sir. இப்போ நம்ம கம்ப்ளீட்டா எல்லாத்தையுமே நியூட்ரலுக்கு மாத்தியாச்சு. Now take any one phase. இப்போ கவனிங்க, this is neutral, this is also neutral. You don't need எல்லாத்தையும் நம்ம ரெடியூஸ் பண்ண வேண்டிய அவசியம் கிடையாது. நமக்கு என்ன தேவை அப்படின்னா ஃபேஸ் டு நியூட்ரல் மட்டும் தான் தேவை. see there இங்க ஒரு ஃபேஸ் இருக்கா, இதுக்கு முன்னாடி நம்ம கன்ஃபியூஷன் இருந்தது, இங்க நியூட்ரல் இருக்கு, அதுக்கப்புறம் இந்த நெட்வொர்க் எப்படி ரெடியூஸ் பண்றதுன்னு தெரியல. நான் டெல்டா ஸ்டாரா மாத்தனதுக்கு அப்புறம் very clearly what I have understood here it is 1 minute. I don't have space now, so let me create some space. Let us remove these things. It is not required now. Okay, that is enough. Fine. Now take the question. இப்போ இங்க என்ன சொல்லிருக்காங்க, I am just selecting only one phase. இது C2. இங்க R phase இருக்கா. இது வந்து ரொம்ப ஈஸியான क्वेश्चनங்க. இதெல்லாம் வந்து ஜஸ்ட் நீங்க ஈஸியா சால்வ் பண்ணிடலாம். 3 times of C1. இதுவும் நியூட்ரல் ஸ்பேஸ்ல கனெக்ட் ஆயிருக்கா. see there இதுவும் நியூட்ரல் தான், இதுவும் நியூட்ரல் தான். அப்ப டைரக்டா இவங்க ரெண்டு பேரையும் கனெக்ட் பண்ணிக்கலாமா? கனெக்ட் பண்ணிட்டீங்கன்னா இங்க R இருக்கா. R ல இருந்து அப்சர்வ் பண்ணி பாருங்க. இப்போ நான் அதை எப்படி வரையலாம்? From R this capacitor and this capacitor both are connected in parallel or not with a neutral common point. See there 3C1 C2. Can I write like this? In between R and neutral only we have C2. In between R and neutral only we have 3C1. Up in between R and neutral these both are connected in parallel. So phase to neutral capacitor. I want per phase capacitor. I don't want total capacitor. அப்ப per phase capacitance என்ன வரும்? Finally per phase capacitor will become C2 plus 3 times of C1. Wow, we found the answer. C2 ஓட வேல்யூ C1 ஓட வேல்யூ ஆல்ரெடி क्वेश्चनல கொடுத்துட்டாங்க சார். see the C2 ஓட வேல்யூ 0.4 microfarad, C1 is 0.2 microfarad. அப்ப இத சப்ஸ்டிட் பண்ணுங்க. C1 க்கு 0.2, 3 times of 0.2 will become 0.6. 0.6 plus 0.4 will become 1 microfarad. Finally we got the value per phase capacitor. That's all. இப்போ ரெடியூஸ் பண்ணி ஆன்சர் போட்டுருங்க. முடிஞ்சல. இனிமே வர்க் வந்து உங்களோடது. என்னோட வர்க்க நான் முடிச்சிட்டேன். இப்போ எல்லா டேட்டாவும் சப்ஸ்டிட் பண்றீங்க, ஆன்சரை கொண்டு வர போறீங்க. ரைட்? From my end I have done all things. இப்போ என்ன பண்ணோம்? Per phase capacitance will be equal to per phase voltage, that is 11 upon root 3 into 10 power 3, that is kilovolt, into 2 pi f into f is 50 hertz, that is also we know 50, that is 1 microfarad, 1 into 10 power minus 6. Reduce this complete expression, you will get the current per phase, charging current, okay, in ampere, and you can drop your answer. I hope you got it. அடுத்த question போலாமா? Now go to the next question. Yes. அடுத்த question என்ன சொல்லிருக்காங்க? ரீட் பண்ணுங்க, நீங்களே சால்வ் பண்ணுங்க. Sir, for the circuit shown in the figure, the capacitance measured between the terminals B and Y is dash. Where is B? This is B. Where is Y? This is Y. அப்ப இவங்க ரெண்டு பேருக்கு நடுவுல capacitance கேட்டிருக்காங்க. Proceed பண்ணலாமா? Yes. Take the network. So let us solve. If you observe the network carefully, this is capacitor. Exactly, sir. CC. And where is the terminal? This is B. Where is the terminal Y? This is terminal Y. Fine, sir. Now, if you go through here, this is one more capacitor. This is CC. And here we have one more capacitor. That is also CC. Right, sir? And they are connected together. Observe the question carefully. They are connecting them like this. Here we have one more capacitor. That is what? CS. And they all are connected together. That's all. That is what they are trying to mean. CS. That's all. Okay, they are connected with the ground. So what? That is a return path. That's all. This is the network actually. So if I will name this point as A, then what about this point? Same point, na? A only. What is the difference between this line? This is short circuited line. If this point is A, then this point also will be treated as A. This point also will be treated as A. அப்ப நம்ம என்ன பண்ணிக்கலாம்? See there. இப்போ B க்கும் A க்கும் நடுவுல இங்க ஒரு கெபாசிட்டர் இருக்கா? Again B க்கும் A க்கும் நடுவுல one more capacitor இருக்கா? Similarly, Y and A, we have a capacitor. Similarly, Y and C, I think I left one more capacitor here. That is CS or something. Yes. One more capacitor இருக்கா? அப்ப இந்த நெட்வொர்க் நீங்க எப்படி வரைவீங்க? It can be redrawn as in between B and A. Sorry, I'm drawing resistor. Yes. So here we have the capacitor. In between C and A, two capacitor இருக்கு. யார் யாரு? CC, CS. Similarly here also same. CC, CS. CC, CS. Fine, sir. நம்ம எங்க மெஷர் பண்ணிட்டு இருக்கோம்? This is B. This is our Y point. இங்க என்ன இருக்கு? CC இருக்கு. Anyway, these two capacitors are connected in parallel. These two capacitors are connected in parallel. Upon net value that can be rewritten as CC plus CS. அதே பக்கம் oppositeல என்ன வரும் CC plus CS. அப்புறம் one more CC, but we are measuring the capacitor from here. That is point B. This is point Y. Now see there, from our observation, if a point B க்கும் Y க்கு நடுவுல these two capacitors are connected in series. When two identical capacitors are connected in series, then the net capacitance will become what? Single capacitor C. இப்போ ரெண்டு பேர் வந்து ஒரே வேல்யூ, இதுவும் C இதுவும் C அப்படினா net value என்ன வரும்? C by 2. Net value will be C by 2. அப்ப என்ன வரும்? Total capacitance will become CC plus CS divided by 2. That's all, sir. அப்ப series முடிஞ்சது. Final அப்ப என்ன வரும்? If you observe CC plus CS by 2. Yes. So finally CC plus CS by 2. This is CC. This is B. This is Y. If you observe from here, see there, this capacitor and this capacitor both are connected in parallel. So what is the net value? CC plus CS by 2. Add பண்ணுங்க. So 2CC plus CC become 3CC plus CS by 2. So what is the final answer? 3 times of CC plus CS divided by 2. Where is the option? 3 times of CC plus CS by 2. So the correct answer is option C. Correct? CC plus 3CC by 2. Yes, option C is the correct answer. That is how we have to solve problems based on capacitor. Let us go through the next one. Yes. அடுத்த question என்ன கேட்டிருக்காங்க? The dielectric loss in the insulation of a lossy underground cable due to leakage current using standard notation. I hope you all know this answer. What is the formula? Directly I can write. From the graph we have to take this. So the dielectric loss can be directly written as V square divided by Xc into tan delta. That is derivation. From this, that is per phase. 3 phase are now you have to multiply by 3. See, this is per phase. Don't forget. For 3 phase, sorry, it will be 3 times of per phase voltage square per phase capacitance into tan delta. Okay, fine, sir. That's so. From this, what you can say, V square divided by Xc can be replaced by what? Xc equal to magnitude of Xc equal to 1 by omega c. So that will be V square omega c into tan delta per phase. For 3 phase, it can be written as V square omega c 3 times of V square, that is per phase voltage. Inge per phase tha into tan delta. Whereas that tan delta is considered as lossy tangent. So that lossy tangent we can calculate by with the help of 1 divided by omega into RC. That is the formula to obtain the value of lossy tangent. Many of you might have aware of this formula. Okay, sir. Let us go through the next question. அடுத்த question என்ன கேட்டிருக்காங்க? Okay. So the 110 kilovolt single coaxial cable XLPE, right? So that is type of insulated material. I'm just requesting you kindly go through this name in Google. Okay, fine, sir. Insulated power cable delivering the power up to 50 Hz has a capacitance of 125 nanofarad per kilometer. If the dielectric loss tangent XLPE equal to 2 into 10 power minus 4, then the dielectric power loss in the cable, how will you find out dielectric power loss in the cable? Just now we saw the formula. In the last question only we saw the formula, right? What we saw, I hope you all have remember. That is V per phase square omega c into tan delta. Just now I have written the formula, right? Now take all the values. We are using XLPE insulated material. What is this? Actually, if you don't remember, sometimes exam like application get wrong. Anyway, I will help you. This cross denotes, X denotes cross. Okay, L denotes linked polyethylene. Simple name only, but you have to remember. Okay. Okay, fine. Anyway, go through the question. We want a dielectric loss, right? What is the formula? V square omega c, single core. So V square omega c, V per phase, omega square into tan delta. That's all. Now what you need to do? Just to collect the all the data. Always in our transmission line, given voltage will be line voltage only. They never give you per phase voltage. If it is given, they will mention. Until otherwise, given voltage is always line to line RMS voltage only given standardly. அப்ப கொடுத்திருக்கிறது லைன் வோல்டேஜ், நமக்கு என்ன தேவை? பர் ஃபேஸ் √3 into kilovolt na 10 power 3 whole square into omega 2 pi f is 50 hertz into c we have to, I think it is given, so that is 125 nanofarad per kilometer. You can consider this. Nanofarad means what? 10 power minus 9. Per kilometer means divided by 10 power 3. You can make it as 10 power 12 also. See, அவங்க question வந்து கிலோமீட்டருக்கு தான் கேட்டிருக்காங்க, அதனால அந்த கிலோமீட்டர் அப்படியே விட்டுருங்க. Per kilometer தான் கேட்டிருக்காங்க. So that is not required. Next என்ன தேவை? Tan delta. Next you have to substitute the value of tan delta. I think that is given na. Last tangent value is already given. How much it is? 2 into 10 power minus 4. Just to substitute all the values, you will obtain the value of P. I hope you all are getting it. That's all. So I hope you all got the idea how to solve the questions. Apart from that, there are very few more questions in our transmission line. That things we will see in the next lecture. With this, we will complete the first chapter, whole chapter. If you have any other doubts, see, during the calculation, நம்ம calculation போடும்போது I may miss some data. Sometimes, rarely it will happen. அப்படி ஏதாச்சும் நடந்தது அப்படின்னா, you please cross check once and correct it by yourself. You no need to wait for me or you no need to ask that question to anyone. உங்களுக்கு தெரியுது சால்வ் பண்ணும்போதே வந்து இந்த இடத்துல வந்து டேட்டா வந்து தப்பா போட்டுருக்காரு அப்படின்னா, you just correct it. That's all, right? You don't need to wait for me. With this, let's wind up the today class. In the next class, we will see the remaining things.